right, so we're going to do 46, 48, 50, and 52 on this one. We might, for the internet here. It says find the absolute max and absolute min values of x on the given interval. So everybody, this is extreme value theorem. This is extreme value theorem because 46 is a polynomial, thus it's continuous. It's on a closed interval of 0 to 3. Now we could graph this and pick the absolute max and mins, but we're going to do it all through derivatives and not graph the function to the bitter end, if we even have to graph it at all. The first thing I say to myself is, well, the extreme value theorem says you better check the endpoints at the closed interval. But we also have to check all the critical points in between, where the derivative is either 0 or does not exist. So the first thing I'm going to do is take the derivative. Does everybody agree this is a pretty easy chain rule problem? And we like that we factor first, even here. And everybody, this factors to this. And I say, oh, f prime of x is going to equal 0. Now we can see from the equation here, there are two zeros, but I can't say there are two zeros here. I can't say that. I can say there is this 0 because 1 is between 0 and 3. The other 0 students often make a mistake on here is they say -1, but is -1 inside our interval? No. So in this case, if this problem was not bound, yeah, there'd be two critical points. But because of the domain on the closed interval, whoops, I would say I have one critical point at x equals +1. Find the critical point, right? And I don't show it. I just did this in our heads, right? Because we solve by factoring. If I plug in 1, I get 0. All right. Nope. I suppose you could do this if you wanted to make sure you understood. You could list it as -1, then cross it out, because it's not in the interval. Now, what do we have to check? We have to check the two endpoints and the one critical point. So I have to check f of 0, f of 1, f of 3. This is where students make a lot of mistakes, because they decide to go to this. This is not f. That is the derivative. That tells us the slope. I actually want to know the max and min's values. So we have to plug back in to the actual function here. Everybody, I don't want to spend time with basic substitution stuff. 0 cubed is 0 minus 3 times 0 is 0 plus 1. The y-intercept is 1. I plug in 1. 1 cubed is 1 minus 3 is -2 plus 1 is -1. And then I plug in 3, and I get the instinct right away that 3 is going to be a big value here, right? 3 cubed is 27, minus 9 is 18, plus 1 is 19. This has an absolute maximum value of 19. Absolute max of 19. Of 19 at 3. And it has an absolute minimum value of -1 at 1. And we just did problem 46. It doesn't, yeah. So I took a second and graphed this, realized that this only goes from 0 to 3. It was bound from 0 to 3. I had let it graph everywhere. Everybody, we can see that there is a minimum here at 1, and we can see that there is a absolute maximum at one of the endpoints of 19. All right? I don't even need to have the graph, though, and this can help me make the graph, right? And we'll talk a lot more about how we know it's decreasing here to the minimum, right? And then it's increasing to the maximum. The derivative can help us identify those spots also. Big deal coming up. We did know that from the values. Yes, we did. But we're going to work on that too. So that was 46. All right. 48 is another polynomial. I think maybe our time would be better spent skipping 48 and doing 50, all right? Because 50, when you look at it, again, is it continuous? It's a polynomial, right? And on a closed interval. So we're going to have to check. So right away, Logan, you know you're going to check f of -1 and f of 2. If you want to write that down immediately, you can. To check maxes and mins, you know you're going to need these values at the end. And that's pretty easy to do. It's 0 when I plug in, and then 4 minus 3, and 27. All right? But we don't know what's happening in between yet. Everybody, do we know that this is going to have a derivative that is continuous, is going to exist everywhere in the interval? Yes, it's polynomial. But we want to find the critical points where the derivative doesn't exist or it equals 0. Do not take x squared minus 1 times x squared minus 1 times x squared minus 1 first. This is a derivative you definitely want to do the chain rule on. So f prime of x is bring the power down, 3x squared minus 1, reduce the power by 1, then multiplied by the derivative of the inside. Now I'm going to factor this so we all see it. 3 times, or now it's multiply 3 times 2 is 6x. You guys agree? And this is where it gets fun. Big bracket. X minus 1, x plus 1 squared. If I can make any of these factors 0, right? So my critical points here would be 0, 1, and I'll list them all, and -1. But what's inside my interval? Well, negative. They all are. -1 is actually one of the endpoints of my interval. All right, so I already got that. And 1 and 0 are inside. So I have to include these two values now, which are critical points inside the interval. All right, let's do some math. 0 squared is 0, -1. This is -1. I plug in 1, and I get 0. All right. Well, we're looking for absolute mins and maxes. So what's the absolute minimum value? -1. Nice way to say it. The absolute minimum is -1 at 0. The absolute max is 27 at one of the endpoints, x equals 2. Now everybody, you'll get the same exact answer if you cube this out and take the derivative, but that's an awful lot of work, all right? An awful lot of work. But we just found the absolute min and max. All right, let's do one more, all right? And you see why derivatives are important all of a sudden, right? I mean, it's really jumping out that we're going like we're bosses at taking derivatives. Last one we're going to do, 52. All right. I see this. Thinking about what Logan said before, we know we're going to check the endpoints. Question is, what do we have to check in the middle? What's going to tell us that? Critical points. Critical point occurs when the derivative is 0 or undefined, or it doesn't exist. I think there's probably a derivative here that's not going to exist. All right. Quotient rule. Quotient rule. F prime of x equals derivative of the top is 2x times the bottom, x squared plus 4, minus the top, x squared minus 4, times the derivative of the bottom, derivative of x squared plus 4 is 2x, all over x squared plus 4 quantity squared. Now this has to be simplified to solve. You just have to. So I'm going to write in red above it. If I distribute, I get 2x cubed plus 8x. Negative 2x times x squared is negative 2x cubed. Negative 2x times negative 4 is positive 8x. Oh, I like this problem. This is why I make sure I use book problems when we're learning. F prime of x is 16x over x squared plus 4. And all of a sudden, actually, this exists everywhere in the interval, doesn't it? I thought it wouldn't, but it does. So where is it 0? Just at 0. You can't make the denominator 0, can you? And the numerator 0 at 0. So we only have to consider one more point. I got to do this function with these values. 16 minus 4 is 12 over 20. Yeah, and everybody, I'll reduce it, but I'm just plugging in because and actually we know that this is, it's an even function. It's an even function, so guess what we know about these two values? They're the same, and what is it at 0? I think it's -1, -4 over 4. And 12/20 reduces to 6/10, 3/5 for both of these. So everybody, this is a really cool one, because what's the absolute minimum? -1 at 0. And what's the absolute maximum? 3/5 at 2 spots at -4, 4. But the absolute maximum is 3/5 because it can repeat. All right. So this takes practice, everybody, and it's integrating your derivatives and all your skills for critical points all at once.